objective of this video is to introduce the dead load and the live load. The information is given in AS NZS 1170.1 2002. So we are using the Australian standard AS NZS 1170.1 2002 for structure design action, permanent impose and other actions. Now for the dead load, that is given in the section 2 of 1170.1 Australian standard. So if I show this one on here, that is on the section number 2, which is permanent access. It's just a one page of informations, but the most important part of this dead load is in the appendix, where we have a table A1. It has given density of the materials, various construction materials, in the kilonewton per meter cube. So I will show you how to convert this density into the UDL load. And another table is table A2 for dead load, which has all the informations and on the materials that is given in the kilonewton per meter square. So table number A2 is given on the page number 20 and table number A1 given on page number 19. Now to start for the dead load, the dead load is denoted by G. It has a self weight of the structures plus superimposed dead load. So the first concept that we want to do it is a G, self weight of the structures. So if I take an example here which has a slab, and if I like to find the unit load of that unit load applied, or the concentric load applied due to the slab, I would suggest that the equation is self weight of the dead load equal to mass times gravity. Mass is in kilogram and meter per second square, so that is in the Newton. Now we don't know mass of this slab because we can't weight that mass. So as I mentioned, table A1 of the Australian standard on page number 19 given the density of the materials, and we can calculate the volume of the structures. So we can calculate mass is equal to density times volume. So the density is given on the page number 19 where we have a density is given for the various materials. So that is the density. Now so we can find this dead load due to the self weight of the structures. Now once we find the dead load, the density and the volume, we can use these equations like kg per meter cube and the volume meter cube, meter per second square, so we can find the load in the Newton. Now that is the point load. Now most of the times we are interested in getting the UDL load due to the self weight of the slab. So if I take the example of the slab and the steel beam under the slab, now the question is how much UDL load is applied by this slab onto the steel beam due to the weight of the slab. So for this case we can use the equation like density times area times G. So that is a difference here. If I need the load in the Newton, from the density we have volume times G with the density, but here if you need the UDL kilonewton per meter, we have a area instead of volume. Now there is a concept here that we need to use to get this area. Now we have two areas. Either we can take height times D, or we can take height times B to get this, either this area or this area. Now to get this area for this calculation of this load, the area that you need to look for is a perpendicular area. So if you are looking for this UDL load, we need to get this area, okay, which is the perpendicular area. You always exclude the length of this direction where you want to load it. So this is the parallel length, so you don't need to use this one D in the calculation of area. So if I take the unit kilogram per meter cube, meter times meter square, so kilogram per meter, if I remove this meter square and meter square, kg meter square, kg meter over square is Newton per meter. Now So the final equation is rho times h times b times g. Now in case if you like to find the UDL load in the other direction, like in these directions, so in that approach we need to multiply this area as a perpendicular area. So if you want to calculate the UDL load acting on these directions, we need to multiply this area. Now G superimpose, if I have a G dead load of superimposed load, for example we have carpet, that how much dead load is applied to the carpet. So carpet has a pressure load which is in the red colors, and how much pressure we can convert pressure load into the UDL load. So G superimpose is equal to pressure. Like for example carpet has a 1 kilopascal of pressure, so pressure, that is kilonewton per meter square, times the perpendicular length B. We always exclude this length which is parallel where we want to find the loading, so we take the perpendicular length, the unit wise kilonewton per meter square times meter is equal to kilonewton per meter. And this pressure we can find it from the Australian standard, which is in the table number A2 on page number 21 or page number 20. Pressure is given in the table number A2, kilonewton per meter square, so that you can convert it by pressure. So this times the perpendicular length that I explain it here, that's the perpendicular length. So thank you very much. This is the end of this video.